Hello, everyone. It is Wednesday, December 1st. It is time for the Knowledge Bolide Hangout, sponsored by Topherspin Meteorites, and today is our 80th in a row. We're starting out with some news about a meteorite we're all familiar with. You guys, this is the Aubrite that was found in Algeria in 2021. It was originally classified as NWA 14185, but that was only for 1,100 grams. There's like 60 kilos of it. Excuse me. So it hasn't hit the Met Bowl yet, but it's been approved. It is now, and you guys want to say that with me? Djoua 101. I know that's not the way the word looks, but that's how you pronounce it in Arabic. It is Arabic for undo. So Djoua 001 is our new Aubrite. So how long till everyone calls it Djoua? But if we can stay true to the Arabic nomenclature of it, it would be really nice, because that's part of the thing about naming meteorites, is they try to give it a little bit of the environment and culture around it. So Djoua. We've had a few people on YouTube reach out, more than a few, swabs of people want to reach out and send samples. So I wanted to put this up there so you can grab a screen grab of exactly how I recommend going about it. There's two real good groups on Facebook called Is It a Meteorite and Meteorite or Meteor Wrong. They are fantastic, and they have a bunch of intelligent people in there. They do a lot better job than sending me photos, because I don't have time to look at them. So this is the best way to get your photos looked at. I do recommend point 3, you do not argue or be rude. There's no need to be. We're trying to help you, and we're not charging you. If you follow the rules right, you possibly could win huge. Jonathan reached out to me and he found a iron something. It is now, according to Jonathan, it is now confirmed as a meteorite by ASU. A 20-gram sample will soon be cut and sent to Dr. Christopher Hurd at the University of Alberta. And we are looking at a iron meteorite to be.
Boo!
So booyah. It can be done. It's not done every day, but I highly recommend the way to go about it is to follow the instructions and go to these professional organizations. And if you're respectful, you will be respected. Talking about respect, the good, the bad, and the ugly, beware of trolls. Did you know that you do not have to purchase anything to use a Google review? You can leave a positive review or a negative review. So that is open to the world. What I'm asking right now is, if you enjoy these videos, I would absolutely love for you to leave honest feedback. I'm not asking for positive, I'm asking for honest feedback in the form of a Google review. The problem is you have a bunch of trolls out there who can do the same thing and they don't even have to buy from you. So it's kind of sad, but not sad. We have a really super awesome event coming up, and I'm calling it an event because we're building the entire hangout around it. And I'm honestly overwhelmed that we were able to get Dr. Ed Liu. He's with the B612 Foundation, and just an impressive man. He serves as the executive director of the Asteroid Institute. So all these Asteroid Day events, this is the foundation that puts them on. He oversees the research that's building a 3-dimensional map of the asteroids in our solar system, and they're protecting us from near-Earth impacts and objects. And they're also mapping, it was explained to me, they're mapping it in 4 dimensions, that 4th dimension being time. So we can look at the inner solar system and where Earth is in danger, and then spread that map out over time and find out when we'll be in danger. So there's a lot more credentials of Dr. Liu. I'm not going to read them all to you, but you should know that he is a 3-time astronaut. Wow. Twice on the space shuttle, and he even flew to on Soyuz to the International Space Station. So he went from, if I understand correctly, he went once from the space shuttle to the Mir space station, and then he went from Soyuz to the International Space Station. Just amazing. He spent 206 days in space, and these are some highlights of his missions right here. So on this one, he went from the space shuttle Atlantis to Mir. That was in 1997. Then in 2000, he was the payload commander. And this is amazing, the lead spacewalker. So he did a 6-hour spacewalk to construct the International Space Station. So we're talking about a man that has credentials and has kahunas, because just 6 months after we lost Space Shuttle Columbia, he was on probably the first rocket available to get back up in space. So just an amazing man. And I can't wait to have him as our guest. I'm truly honored. And it's going to be quite an interesting event. So hopefully you guys will come live, or if you're not able to, watch the replay. I do recommend that if you have questions that you would like us to ask the doctor, please drop them into YouTube comments and I'll put them on the list and see if we can get to them. Comments on this, on how awesome this is, guys?
Oh, that's good. It's going to be incredible. So this hangout is going to last 6-7 hours.
No, don't be mean.
The actual time with Dr. Ed Liu and B612 Foundation is going to be about 45 minutes, a half-hour presentation, 15 minutes for questions. So they will be vetted questions. And then it's just going to be us, after they drop off, it's going to be us patting ourselves on the back and geeking out for the next hour. And the recording is 100% optional at that point, because we've already hit the home run grand slam. There's nothing more that can be done.
Awesome.
So,
what is the day?
That is 2 weeks from today. It's December 6th, 2021.
December.
Yeah. And once again, I think it was Scott McGregor to get us together. So I really appreciate that.
Are we going to make him an honorary member of the Hangout?
Oh, the entire crew at the B612 Foundation is going to be honorary members. Yeah,
right.
Lifetime members. And honestly, they've reached out to us to also start our own Asteroid Day events. So these are events that go on around the globe, and they're not just tied to the June anniversary. We can do them all year long. So I will be rolling out an announcement about the Topher Spin Meteorites Asteroid Day event when that happens, but it is in the plans.
And Topher, would you give the date one more time?
Yep, it is December 15th, 2021.
Okay, great.
With that, we have a growing need to spread accurate information and expand our understanding of meteorites. So with that, we have our resident geologist, Mike Kelly, who's going to explain to us Ureilites. And that's our topic for today is Ureilites. So Mike, if you're in the building, if you could take it away, man.
So this was my original cover slide, and we'll cover this in a little more detail, but this is kind of the current thinking as to exactly what the history from formation to us getting Ureilites looks like. And it's kind of complex, and Ureilites are kind of one of those enigma meteorites. There are a lot of them out there, but there's still a lot of gaps in our knowledge base on what we actually know about them, and we'll cover some of the cooler aspects of that. And we'll probably go back to this diagram a little bit as we talk about it to kind of see some of the steps in their formation, disruption, and everything else. So the Ureilites started out on September 4th, 1886, right around the little town of Novo Uri. There's a couple different spellings of that, but basically in the morning, several peasants were out there plowing their field about 3 kilometers away from town. It was a gloomy day, as recorded by a professor or teacher, Barlachansky, in one of the nearby towns. And this is his accounting. And the whole sky was covered with clouds. Suddenly, a light appeared all around. And for several seconds, a strong report was heard, like that of a cannon or an explosion. Then came a second louder noise, the loud noise of a fireball falling to earth a few meters from those peasants. Frightened, they all dove to the ground and remained still for a long time. And finally, one of them, who was a little more adventurous, thinking that they were in a strong thunderstorm and thunderbolts were falling all around them, finally one of them got up and went to investigate the nearby sound, and in a small hole in the ground, in the middle of that hole, he went ahead and found one piece of what was later recovered of 3 total pieces of the NWA Ureilite meteorite.
Wow.
So all classic meteorites should have a great story to them. So again, 3 stones were found. According to the reports, 2 of those stones were then broken up and eaten.
Oh my God. What?
leaving but 1.9 total kilograms to be found in collections worldwide nowadays.
Wow.
Oh,
Some of the
Hard
history of meteorites just blows my mind.
Yeah, so we're kind of on a roll here. You know, the last couple of type falls we've talked about have all had incredibly intriguing histories to them. So this was actually a fun part of the research, because a lot of the other meteorites, it was pretty easy to find out how they came about with the naming. This one was a little more buried. So the Ureilites became a class when Asteroid, I'm gonna butcher this name, Asteroids Brazina added them to a modification of Tischermack's classification, who we talked about 1 or 2 times ago, who had previously modified Gustav Rose's classification of meteorites. He was the one who happened to coin the term achondrite for us, which is still around today, and described 4 achondrites at the time, 3 of them being Ureilites. So there was not many of them when he coined that term. And the interesting thing to kind of put another twist in the story is Nova Uri is not actually the oldest Ureilite fall. Dailanpur in India in 1872 is actually older than Nova Uri, but Nova Uri got the type name.
Wow. That's crazy.
Moving on to the next slide, Topher. So composition wise, so Ureilites are an achondrite, like we talked about, of the original achondrites that kind of were what they looked at to form the group and say, hey, these are stones from space that lack chondrules in them. And they are from differentiated parent bodies like the rest of the achondrites. And they're considered a type of primitive achondrite. So what that means is if you look at the whole rock composition and the oxygen isotopic ratios in there, they're very close to either chondritic or what they call subchondritic, almost chondrite-like, as far as their overall bulk composition and their bulk oxygen isotopic composition to what you would find in chondrites. The Ureilites are almost all monomix, so that means the whole meteorite is composed of the same single mineralogy, and a lot of times that means that they're unbrecciated, so they're not made out of broken up pieces of rock. They're just one solid monolith. Composition wise, they are made up of olivine and pyroxene, and in this case the pyroxenes are a type called clinopyroxenes, so that just means that their mineral structure is different than the orthopyroxenes. It follows a different kind of 90-degree pyramid, 90-degree rhombus structure. There are 3 different types of Ureilites if you break them down by composition, and they basically depend on theory being how deep they formed within that parent body. The majority of the Ureilites are a combination of olivine and clinopyroxene in the form of pigeonite, which is basically just, it's a calcium, magnesium, iron, silicate mineral. Some of them are formed a little more shallow, and they will have a predominance of olivine and orthopyroxene. So again, the clinopyroxenes and the orthopyroxenes, they're both silicates. It's just a matter of what crystal structure forms. And then the last group is the deep formed Ureilites, and those have a composition of olivine and augite. Besides the main 2 minerals of pigeonite and olivine, you'll have accessory minerals that include iron, nickel, metal, like almost all meteorites, troilite, iron sulfide, and along with chromite and a normally large amount for an achondrite composition of carbon. And that carbon comes in the form of either graphite, normal diamonds, or ionzellite, which is a kind of stressed diamond with stacked planes in it. And depending on whose research you look at, there's either between 3 and 7% carbon within the Ureilites, which is high for an achondrite. Which also kind of gives them a tie to the fact that they're probably from some carbonaceous-based precursor material, kind of like the CVs, as far as what chondritic material or chondritic-like parent body they started from. One of the predominant structural features that they show are triple junctions. So if you look at the crystal structure, where 3 crystals come together, they form little kind of triangular interfaces between the crystal grains. And between a lot of those grains is where all that carbon accumulates. So that's, they call that like interstitial in between the grain boundaries. You'll get the accumulation of the carbon in the diamonds. This is a diagram I borrowed from C.A. Goodrich et al. From 2004. And this shows you what I was talking about the pyroxene compositions being from different depths within the parent body. So this represents the, you know, the kind of the surface of the Ureilite parent body. And then you'd have those orthopyroxene based Ureilites that are shallow. And then you'd have the pigeonite based main group where the majority of them come from, which are mid-level. And you have those augite based Ureilites forming deeper. And they're thought that they form from partial melts. So all this material gets laid down. Some of it gets heated up more than other material, starts melting and starts, you know, rising as bubbles towards bubbles of magma towards the surface of the parent body. And it either cools at depth or some of it makes it all the way to the surface, and you get volcanic eruptions on the parent body, which we'll talk about some interesting hidden things later about the Ureilites. So one of the things that's really neat about the Ureilites is they're very compositionally uniform for all the different Ureilites we have. And one of the things that's thought that happens is they were a very hot parent body when it actually got broken up and disrupted and then kind of reformed into what they think was a rubble pile. So looking at the minerals and the uniformity, they can actually approximate what temperature you know, this magma formed at, which was 1100 to 1300 degrees Celsius. One of the interesting things is they can also look at cosmic ray exposure of the Ureilites, and they actually have a very short cosmic ray exposure. So what that means is that big disruption that caused the original parent body to break up and form either one big parent body again as it reaccreted, or multiple little parent bodies, or you know, daughter parent bodies, that's what they call them. Was not the big hit that brought the Ureilites to an Earth-crossing orbit. That came much later on, about 35 million years ago, they're thinking, based on how much cosmic ray exposure they find on some of these things. The Ureilites were the first meteorite ever to have diamonds found in them. And that was found only 2 years after the fall of Nova Uri. So 1888, diamonds were found inside the Ureilites.
Mike, do you think those diamonds, those nano diamonds and everything are due to the depth that the Ureilites formed at?
So there's a couple theories on that. It used to be a predominant theory that they used to think that the Ureilite parent body was actually of a certain size, almost like a Mars or larger size parent body, because you would need enough pressure to form diamonds.
Yeah.
But subsequent experimentation, they've been able to produce the diamonds by shock metamorphism. So just that large impact. So that kind of throws a monkey wrench in the, hey, it has to be a certain size. And the thinking is that, yeah, it's their impact shock form diamonds from a very short pulse event. So it happens very quickly, but at extremely high pressure to partially turn some of that graphite into diamond.
Awesome. And Mike, hopefully I'm not stealing any of your thunder, but I wanted to just make a comment that our resident classifier, Daniel Shake, made, that these are nano diamonds. You're not going to see them. You need better than a back scanning electron microscope to see them. So you need heavy instrumentation to be able to see these. They're not gemstone diamonds.
Yes, they are certainly very, very small scale.
All right, thank you.
Yeah, one of the other interesting things is the first asteroid that we ever spotted on a Earth colliding orbit, which was 2008 TC3, was a Ureilite. And that was back obviously in 2008. And on October 7th of 2008, TC3 entered the Earth's atmosphere over the Sudan, where it disrupted up in the atmosphere. And initially they thought nothing would have made it to the ground, but they did multiple searches anyway. And in December, they actually turned up like 600 plus fragments of 2008 TC3, which was then classified and became the Almahata Sitta meteorite fault.
That's amazing.
And it's a real oddball too, because it's a whole bunch of different classifications.
Certainly is. So one of the other interesting facts is we were saying, these things are kind of oddballs. There aren't really any major amounts of basaltic material in the Ureilites. So we kind of have this level of material that's from deeper in the planet, but you would typically think you'd have basalts forming at the very surface of the planet, and we haven't found any. And so one of the theories behind that is that since there's such a high amount of carbon in the Ureilites, they're thinking the magmas that form an incredibly high amount of gas volume of carbon monoxide and carbon dioxide, enough to the point that any of the magmas that reached the surface and exploded as volcanic eruptions would produce such violent eruptions that the material would clear the parent body and get blown off into space.
Wow.
And simply not be present on the parent body. But yeah, it's kind of odd
that might have caused the shock too.
Yeah, it's the shock's in really high, I guess, gigapascals. I think they're 100% relating that to the very, very large disruptive impact that they're thinking broke the whole thing up into just some meter wide chunks. So Ureilites by the numbers, again, this is actually a very large group of meteorites relative to the achondrites. So this follows right behind the HEDs as far as number of meteorites that we have for achondrites. So there's 594 plane type Ureilites. And again, those are monomic by definition and are olivine and pigeonite for the most part. There is one put in there as a Ureilite monomic, which I kind of wrote down there silly next to it because by definition, that's the majority of them. So it's really just one of those 594 above.
Yeah, why point that one out?
Yep. And then, like Pat said, Almahata Sitta was a very curious one because there are 29 Ureilite polymix, and Almahata Sitta happens to actually be a polymixed Ureilite. So that means it's made up of multiple different types of rock from the parent body. And this ties back to what we were talking about with breccias. So that would be a regolith breccia from the Ureilite parent body is what those Ureilite polymix are. And then there are 6 Ureilite anomalies. And actually, the Almahata Sitta was put into the MEPL as Ureilite anomalous, just because what Pat's pointing out, it has a lot of xenolithic material. So material mixed in with the Ureilite material, but that's not actually from the parent body. So if you want to go back to that multicolored slide, Dover.
Yep.
So we kind of covered most of the history of this a little bit, right? So the Ureilite parent body formed and differentiated, and that's where you see the big, jawbreaker, multicolored ball there. Then a large impactor came and hit it, and you see the impactor coming from above. And again, high shock. So theoretically, that's your formation of the diamonds. And the whole thing broke up into pieces and then reformed either into one reaccreted body or multiple little accreted bodies. And then it's kind of moving in a clockwise direction. Then all these different other impactors ran into that daughter parent body. And you can see there's EL type material, there was ordinary chondrite type material, there was carbonaceous chondrite type material, and Rumarudi type material all hit and was embedded into this rubble pile. Pieces of that came off, and one of those mixed pieces with all those different bits in there was 2008 TC3, Almahata Sitta.
That's crazy.
And so the process ends with us receiving both these little bits of polymixed Ureilite that are regoliths with all these xenoliths in them, and then also the main group monolithic Ureilites that we find as a very common, more commonish type achondrite right behind the heads.
That's a phenomenal explanation. Thank you, man. So Golpara is a very old and very well-studied Ureilite, just because like
like Nova Uri, it's old, so it's been around long. We've had a lot of time to look at it, so it is historic. So that's kind of cool, and you can find. Kenna is a great story. So that's an American Ureilite found in New Mexico, and that was found by Skip Watson, a guy who got into collecting meteorites when he ran across one while hunting arrowheads. So he took one of these meteorites he found, which was Kenna, which was 24 pounds.
Oh my God.
Yeah.
Winner.
And he sent it off to a gentleman named Glenn Huss of the AML at that time out in Colorado, who proceeded to attempt to cut it and burn through 3 saw blades, at which point they realized that it was not your ordinary meteorite. Again, because all that diamond content in there. And it was finally classified as a Ureilite, which at the time, there were a lot less of them back then. So Glenn Huss went back to Skip Watson and said, I'll give you $1,000 for the big chunk. And Skip Watson said, that sounds like a really good deal. And got $1,000 for, I think it was about 20 pounds.
Dang. Which
at the time sounded like a good deal. But if you look at the price of Ureilites nowadays, 20-something pounds, he could have probably been sitting high 100,000s, low millions at the time.
For an American one too.
Yeah. 4 years later, the Smithsonian went back to Glenn Huss and said they wanted a piece of that material. So he went back to Skip Watson, and Skip received $4,000 for the smaller little piece left.
Wow.
So you can imagine, like I said, over time, it's pretty interesting. And then the last one I have on there is Dingo Pup Donga, which if you haven't scrolled through the med pool, I rank that as maybe one of the coolest named Ureilites out there.
Yeah, that's awesome.
Yeah, so just a little quick aside there. The Dongas are sheep and cattle and I think even camel stations in the outback in Australia. The nomenclature committee uses local place names, and I think they had a lot of fun in Australia. Great stuff, Mike.
Yeah, we totally appreciate you educating us week in and week out.
I have a question. What is the great story of Kenna? Because I have a specimen of the Kenna Ureilite, so I'd like to hear that story.
So again,
story.
It was found at a time when there really were not many Ureilites out there, and it kind of changed Skip Watson and put him on a trajectory to become a great meteorite hunter. And Huss kind of told him, hey, nobody really makes a living out of hunting meteorites. And Skip Watson is a prolific finder of Western meteorites. And he basically realized that, to go out in the West on some of these plowed cleared fields after some of the very, very large aggressive storms would expose a lot of meteorites. And he found a lot of meteorites. And he was actually also one of the major finders of Portales Valley, which happened to land right near him. So he's got Kenna and Portales Valley under his belt as 2 amazing finds.
No doubt.
Along with many, many other U.S. Western classics for meteorite finds. But yeah, I mean, he got paid $5,000 for Kenna, and now if you take that whole 24 pound mass and you evaluate it, he could have been a really rich man off of it if he knew it at the time.
And Michael, wasn't Skip the guy who really popularized hunting the blowouts in the desert and these little areas where the sand is all excavated and it creates desert?
Yep.
Yeah, he's got, last I knew, he was somewhere over 200 classifications.
Yeah, he's been very prolific, contemporary of a lot of the very big names. Like I said, Huss and Haig and the other big names of the time. He built up a very strong hunt knowledge, just by intuition, by understanding the terrain and how things worked out there.
Wonderful.
That's awesome.
And we got Roberto on the line. Roberto, that upper left one was yours on that first one.
Oh, nice.
There we go.
Took a macro shot to give you an idea, and you can kind of see, some of the grain boundaries even through, the desert varnish in there. You can see how they come to kind of little triple junctions in there, where you're getting a little bit of the accumulated. In this case, it's cutting, uncleaned cutting, dust following those grain boundaries. The second picture down there was just the kind of interstitial nature. You can see how the matrixy, dusty carbon builds up in there between the grains. Looking at the next one, I'll actually show this one off later. That's a large C1/2 carbonaceous inclusion in a piece of polymiced Ureilites. That's one of those 29, and that's 14228 up there.
Wow.
These are just a couple different shots of the cool little grains and bits inside the polymiced.
That is wild. And that's a recent classification.
Yeah, sure. That's a recent classification. It was a relatively low total known weight, and that belongs to Noordin Azamet, Saharak.
That's awesome. Yeah, he's
Almost looks opalized.
Yeah, it's got so that reflection is chatoyance within the crystal grains.
Right.
Well, Mike, once again, what a terrific presentation. Thank you so much for preparing it and then presenting for us. Really, every week.
Thank you.
Appreciate it.
Yeah, no worries. And
Really good one.
go out and find yourself some great Ureilites.
Now we have our resident thin section photography expert, Marissa Fenady. She is going to explain to us what we're looking at and how awesome it is. I don't know how she got these pictures, guys. I have a few pictures I'm going to show and then a video. Look at that.
Keepers.
Yeah, I think she wants to introduce the next pictures. Is Marissa on with us?
Yes, I'm here.
Hey.
Hey, Marissa.
Hi, guys. Yeah, I've just been playing around with some more wavelengths, and I've got 2 different wave plates that I can put into the microscope and see. Basically, to my understanding, I want to clarify that I'm still learning, and this is extremely difficult stuff to learn. So
Yeah.
I'm just enjoying pictures, and I'm trying to learn as I go. But the different wave plates, from my understanding, I think just bend the light a little differently, and you get different color variations that can help you determine mineralogy. So I've been playing around with those, and I've been taking plain polarized light photos. So been trying to get different variations and trying to learn this stuff so I can identify different minerals.
These are amazing photos, Marissa. I mean,
Magnificent.
Yeah, that one's probably my best one, since I got completely to the edge in focus. I don't know if I can do that again. Everything kind of just came together beautifully, and my phone decided to cooperate very beautifully.
Yeah.
So I have no idea how often I can do that. That just was a fluke, and it just came out perfect.
A Rembrandt of cosmic art.
Angulated pieces. It's beautiful.
Yeah, that's inside I believe a PO chondrule. And it's a pretty big chondrule, and it's in NWA 4560. So I got it dead center right in the middle, and it was just beautiful.
And all the shock lines through the grains, there's something else.
Yeah, that's such a beautiful photo. There's so many different colors in the olivine, and the composition of those colors is a cool intersection of high art and science.
No doubt. Look at this one. I don't even know what kind that is.
That's
the barred olivine.
Yeah, that's a barred olivine, and I think it's a little complex since the bars are at different angles.
Yeah, it's kind of spongy looking.
Yeah,
that one
Almost the petrified wood.
Interesting pores along the edge there.
Yeah,
I wonder if it volatilized.
Yeah, I'm trying to figure out what those elongated circles are along the edges, and I'm leaning towards they might be trollite or iron because they're not showing up in anything else. I still have to put reflected light on this and find out what those might be.
This is wild. You can really see the trauma this thing has suffered. Look, they're all just broken and staggered, but all linear. They're all parallel, the fragments. Even this one here, it's straight. Yeah. Very, very interesting, Marissa. Can you explain this one to us?
That is a new technique I'm doing for more artistic reasons. I'm mixing different photos together to make one image. So the bottom half
Is that how you did it?
it's a full wave plate photo, and the top half is just normal crossed polarized light. And once I started to get these different wave plates, it just popped in my head that I had to do this and try and make different composite images to make much more different thin section photos. I've never seen this done before, so I just thought it would be beautiful.
Look at this accuracy.
Oh yeah, I'm a perfectionist. I did that by hand.
That is fantastic.
I don't quit until I get it dead on.
That is great, because just like Pat said, you can explain how to put paint on a palette, on a frame and canvas and stuff, but you're not Picasso. Like, you can explain to me how to do this, but I'm not going to get these results.
This is such a beautiful chondrule too, and that one too.
This is obviously the same chondrule, but we're looking at it under a different wave plate. Is that what you're saying?
Yeah, that one is
it's the same as this one.
Yes, it's the same as that one. And for that image, that's also a split image where the right side is with the full wave plate and the left side is just plain polarized light.
I didn't notice that.
What is a wave plate exactly, as opposed to polarized light?
So this is a really deep subject, but the wave plate is a piece of material that is placed in the optical path that shifts the light by either a quarter of a wavelength or one full wavelength. But the effect is that it shifts the colors in the Michelson chart that are used to measure refractive index of the crystal itself. Yeah, and here the thin section is being rotated between being rotated on the stage between the light source and the observation port, and there's a polarizer on each side of that. So it's transmitted cross-polarized light with a wave plate in the train.
Marissa, thank you so much for including this and allowing us to partake in your art/science/obsession. Really good job. Thank you so much.
Stuff, Marissa.
Thank you.
Marissa. Kudos.
All right, we are starting our show and tell with Ureilites, and we're going to be checking in with Roberto Vargas first. Roberto.
How's it going, guys?
Very well.
Cool. So I just have one Ureilite to show off today. Bam.
Whoa.
So this is this is NWA 14451, I think. It's my new classification. I sent it in. Tony Irving did all the science on it. It's not for sale yet, but this is the piece that I'm keeping.
Oh, yes.
So that's technically the main mass. And the cool thing is when I got it, it all fit together like a puzzle piece.
Oh, sweet.
Yeah.
Uh-huh.
So that's the science on it. one of the things that Mike Kelly brought up that's actually pretty interesting is that one mentions augite in the write-up, which I guess is not super common. Of the like 600 or so Ureilites, this is one of, I think you said 69 that.
Yep. Yeah, I looked up yesterday. It was like 69 of them.
Wow. That's awesome. It's nice to have that called out.
Yeah. So yeah, that's it.
What's the total weight of that one?
968 grams.
That is sweet.
It should be hitting Metpool within the next update or two.
There we go. This is quite possibly, now this was not rehearsed, this is quite possibly the first time ever that we've had multiple looks at the same meteorite. I received a shipment from Roberto Vargas, the contents of which I cannot reveal. But Mr. Vargas was quite generous.
Whoa.
Sent along a slice of NWA 14451, his brand new Ureilite.
That is beautiful on the inside and on the outside.
And just looking at this thing, so I'm rotating the polarizing filter here to get different looks.
Yeah.
One can tell this thing is harder than you know where. This had to be torturous to cut. They are notorious for moving saw blades around.
Our resident Ureilite expert today, Mike Kelly, cut that for us.
Oh, nice.
Oh,
Nice. And here's the other side. And this isn't super high magnification, but you can still get an idea of the triple junctions in this view. Yeah, this is fresh out of the box. So
That's
thank you.
fantastic. I absolutely love that. That is a actually fresh looking Ureilite.
Yeah, it's a very beautiful thing. It's very dense, and I would like to know more. So I generally say no to achondrites because my wallet is of a finite size. But Mr. Vargas included this one as a freebie in my shipment, which is
oh my!
Free meteorites is better than free beer.
Yeah.
Thank you, Roberto.
We can always afford free meteorites, man. Awesome. Thank you, Pat. I appreciate that. We have Greg with his hand up.
Well, as I mentioned, I have the Kenna here.
Oh
I
yeah.
have all in membrane boxes. This one I got from Dave New back in the 90s, 3.2 grams. And then Daralgani 319. This is polymig breccia.
Oh, so one of the rarer ones. Nice.
And then NWA 8049.
Wow.
Sizable.
And then 2218. Right there. And
I think we have
very-
the most Ureilites in one collection of the crew right here.
And then this is
Oh, you got.
tiny piece on the
Oh,
Almahata Sitta. Can I share my screen really quick, Topher? Is that possible?
Absolutely.
Okay. Okay, here I published a review article in a Meteorite magazine, which closed production a few years ago, been replaced now by Meteorite Times. But they actually found extraterrestrial amino acids in a Ureilite, the Almahata Sitta here, and they found glycine, which is the simplest one, and then L-alanine and D-alanine, and they also found polyaromatic hydrocarbons, phenanthrene, pyrene. Naphthalene is mothballs, by the way.
Really?
And yeah.
Well, it's a well-preserved meteorite.
Yeah. So isn't that cool? And then here's the chemical structure for an amino acid. You have a central carbon, and you have 4 different groups. This is the amino group. That's why it's called an amino acid. This is the acid group, the carboxylic acid. So that's why I call it an amino acid, because it has a basic portion here and a weak acid here. and then a hydrogen, and the R group is what you attach to it, like another H, CH3, and etc. And then when you have 4 different groups around the central carbon amino acid, you have what's called chirality, handedness. So you have D and L, and L is what living organisms use, and was discovered in carbonaceous chondrites initially that you had a racemic mixture, 50-50% of E and L forms, and then was discovered recently that there's actually an excess of L forms in the carbonaceous chondrites. So life used what was in excess, the L forms. That's kind of interesting. But the fact that you have amino acids and these polyaromatic hydrocarbons is interesting. And these are the primary literature sources here.
Wow.
So
that is fantastic, Gregory. Thank you so much. Like that's a
Awesome.
yeah, that is a really amazing to have someone like you write an article like that and be on our Hangout, man.
Oh, I love this Hangout. This is incredible. You don't have anybody that knows anything about meteorites to talk to, so that's what's cool about it. Seriously, and they get excited about it, you know?
Yeah. We are moving right along, and we have Mike Kelly with Ureilites.
A couple of the ones that I have. Greg had already showed Kenna, so this is my little bit of Kenna. And again, it's a pretty cool American one. I'll go after this, try to go pull and see how many American ones there are. I know I ran across Bob Verish had found one that was a little like 2 grammer, but it was like super oriented, and it was crazy. Because I'm guessing there are not all that many American Ureilites out there. Pat, congratulations on your little piece. This is my tiny little piece of Roberto's new classification. If you get a chance, get it out in the sunlight, because it's got some crazy looking kind of reddish tinted glints in it, which I would love to figure out what that is.
Wow. Okay. Yeah, I'll check it out in direct sunlight. Yeah,
it's definitely something that I didn't have in the other Ureilite.
Hey, Roberto, I'll check mine out too when I get it.
This was my piece of the polymict. So you can see up there at the 1 o'clock, that's that big C1/2 carbonaceous inclusion in there.
Nice.
And under the microscope, yeah, it's cool to see the breccia in it and all the different pieces in there. There's some big bits of olivine in there under the scope that are nice and green looking. So that's kind of a cool one. And then, you can't love the Ureilites without having your own tiny bit of the original.
Nice.
It's named after Palladium, for the original statue that protected the Greeks.
And so that one was not digested by anybody.
No, this one did not pass through any digestive tracts, to my knowledge, before arriving here. So that's the rest of them. So I keep everything divided by type boxes. These are all various pieces of Almahata Sitta, and I've shown this off once before, but since we're talking Ureilites, there really is a huge, really cool, diverse bit of Ureilitic material in there. So even the things that are monomic Ureilites, there's fine grain, medium grain, and coarse grain Ureilites. There's little things like bits of H chondrite in there. So there's H5-6 material. And the one thing that was great about Almahata Sitta was all those 600 and something pieces, they kept track of each individual one.
Oh,
and
really?
And each one of those pieces is getting studied individually. So this is a piece of fine number MS11, and they're all labeled like that. And all of these pieces here have ties back to which stone they came off of, MS160. So there's a lot
way cool.
A lot of cool different things in there. Here's MS150, which was a EL6. So non-Ureilitic material inside there. And again, these are all very small little specimens.
A lot of variation in the body.
Yeah, crazy amount of variation.
That one, yeah.
Including CB, carbonaceous bencubanite type. Yeah, there's all sorts of good stuff in there.
That's a massive collection of bits of Almahata Sitta.
Yeah, I was shooting for a while to try to get all the subtypes, but they kept coming out with more of them.
Wow. That also was a big Arizona tie-in too, in the Catalina Sky Survey was where that one was found. And the finder's name is slipping my mind, but I happened to be in Tucson that year. And from Ann's room, I bought a piece of Almahata Sitta and had the finder of the Asteroid 2008 TC3 sign the back of the sample card for me. And that one's
That guy,
well.
Nice province.
that guy in that place is lucky because I believe they are responsible for all 3 of the known pre-orbital trajectories that have been followed in.
Doing the good work.
Yeah. Well, good work and a lot of luck.
Thank you so much. Really appreciate that. I have a Ureilite main mass that I want to show off. This one is the main mass from NWA 13239. It's 115 grams. And this is like pretty much the only Ureilite in my collection.
Wow.
Let me get
Oh,
this case out of here. Okay. Yeah, so it has a really unique exterior.
Yeah. They just look hard.
Dense. Yeah, absolutely 100%. It is like the hardest, densest meteorite that I have. Even on par with some of the heavy metal melts. But this is my 115 gram main mass of a Ureilite. So I'm super happy with it because a main mass and a Ureilite. So I checked 2 boxes off.
And it's good size. Wow.
Yeah. Now here is my brand new Ureilite, and this one is substantially larger. This one right here, I just got this morning.
Wow.
Do we have any guesses at the weight?
260.
830.
I'm gonna say 500 grams.
He's the closest so far. 444 grams
Nice.
of Ureilicious delight.
Is it classified?
Ureilicious.
It is not classified.
Nice.
And now that you mentioned that, allow me to take the next step and say, hey, have you ever thought about being in a Met Bowl? Would you like to be the main mass holder of your very own Ureilite? If so, contact Topher at Topher Spin Meteorites. This puppy is definitely available, but I'd like to remain a mass holder of it. So I'm willing to split this with somebody. Yeah, I just got it this morning.
Wow.
I haven't had a chance to really review it yet because I've been at work, but super cool and very, very dense, extremely solid meteorite. Those are literally the 2 Ureilites that I have in my collection. They're kind of expensive. They're rare. They're hard to get. They're harder than hell to cut. So that's why when you see slices of Ureilite, know that you're paying for all the material between that and its sister slice, as well as the 2 hours it took to make that slice. And then every 5th slice, you're paying for a blade.
Yeah, and pile of saw blades. Yeah.
So there's a lot of expense that goes into cutting Ureilites, but they're extremely rare. And through today's education with Mike Kelly, we've learned to appreciate them from a scientific point of view as well. Let's check in with Art Wagner with something that looks familiar.
Yes, this is a Ureilite that I purchased from Topher, NWA XXX, and it was found in 2019 and identified by Dr. Tony Irving. I think there's one lithogy in here, so this would be a monument Ureilite.
Correct. Yeah.
The opposite side is gnarly.
There you go.
Yeah.
Yeah, the Ureilites are really gnarly and and just weird looking. They definitely don't look like the normal meteorites that we all think of, you know, an oriented, dripping, fusion crusted meteorite crust on it. But talking about crusty things, Bruiser, sorry about that. How you doing, man?
Why did I know it was the lead into me? All right, so I got something new. This is provisional NWA 14448. It's a Howardite.
Ooh.
Ooh.
Nice.
So, as well as being a garbage pile, the reason that I've got my hand in a glove is because of this.
What the heck?
Oh.
Yeah. So, has anybody else ever seen an iron inclusion in a Howardite?
No.
No.
That would have to be part of the impactor, I think, but that is exceptionally large for being an impactor bit.
Yeah, that's I don't know, maybe about a centimeter across, I think.
Oh, yeah,
That
easy.
is,
That's
that
huge.
is wild.
Yes.
So
That is the biggest metal inclusion that I've seen. Look at that. That is
yeah,
crazy.
there you go.
Jeez.
Wow.
Yeah, that is by far the largest metal inclusion I've seen in any Howardites.
Yeah, I haven't seen any, but I figured, hey, you guys should probably be interested. I got this from Craig. Everybody's interested. I don't know.
Wow.
What-
Yeah.
what the deal
You
is.
show it to us just in case we're interested. Yeah, we're interested.
Is there a
It's
sister
not like I'm
slice?
selling it, but it's like,
There's a few of these.
like, yeah, I opened out the package, I'm like, whoa.
Honorary Professor Pat. Pat, there was a YouTube question that hopefully you can answer now that you've had a week to do it. No, it was about potential non-destructive ways to analyze or potentially classify a meteorite. And the reason they were asking is sometimes there's a oriented meteorite, even an oriented iron, that you would not want to cut for aesthetics, but there still may be some secrets that can be unlocked through X-ray technology. So Pat, over to you.
Yeah, so this is a very interesting question, and I think a very timely one in that some of these meteorites are just too pretty to cut up. So there's been a lot of work over the years on non-destructive testing schemes in a number of different disciplines, but they certainly apply to meteorites. So one of those schemes that has been applied to some degree is CAT scan, or computer-aided tomography, where an X-ray source and an X-ray detector are spun around a sample that then a number of slices are taken in the z-axis, and then they're reassembled in a computer that you could then go and rotate the volume and look at the stuff inside. That has been used to look at armored chondrules. In fact, there was a paper at the Meteoritical Society meeting this year in Chicago, where a researcher looked at a chondrule that was present kind of at the corner of a couple of cut faces. But this chondrule was armored, but beyond that, it actually had two layers of armor. So there was the chondrule, a layer of iron or sulfides, a fine grain sulfide layer, and then another layer of iron or iron sulfide. And this chondrule was shown in 3D. Now that really isn't a classification technique. It's more of a
morphology technique.
Yeah, exactly. To try and see some of these 3D structures. That same scheme. Now this is not. They don't just trot it down to the hospital and throw it in the CAT scan machine. This is a very special machine that is has much finer resolution and can only handle small parts. That technique was also used on one of the Apollo core samples, and Topper and I in 2019 were able to go to the University of New Mexico at Albuquerque and hear a number of technical talks at the 75th anniversary of their Institute of Meteoritics. And one of those talks was given by Jack Harrison Schmid, and he described some of the 3D X-ray tomography that they had done on this core sample while it was still in the tube. And so, you know, to plan the opening and the research that they were going to do on that core sample. So the CAT scan technique is really not appropriate for classification, but it can give some additional information. Now, one scheme that has been proposed, in fact, there's even a Facebook group by this name, is to use XRF guns to classify meteorites, and that's particularly appropriate for nickel iron meteorites. But it turns out that it is incomplete. It's not enough information to really do classification properly. For classifying irons, we don't cut a petrological thin section in the sense that we do for stony iron meteorites, because we're just talking about iron. So instead of a thin section, it's a thick section. And pretty much anything is thicker than 30 microns, but they do a thick section that is polished on the top, and then it's put into the scanning electron microscope, and elemental analysis is done, but in a very, very fine sort of way, looking at a very small spot size. Recently, there was a possible meteorite that was posted in one of the Facebook groups that we had a long discussion about, that was observed with an XRF gun, and the finding, now XRF is X-ray fluorescence. So an X-ray beam hits the target, and then that excites the electrons in the atoms to jump up to a higher orbital plane. And then when the X-ray is removed, they jump back down to a lower orbital plane, give off a specific wavelength and quanta size of electromagnetic energy that's picked up by the gun and read off, interpreted as different elements. This was a nickel iron meteorite that had huge, thick taenite bands in it. So very, very coarse, much coarser even than Campo de Cielo. And the XRF spot was all in a taenite band. It wasn't the appropriate combination of taenite and camosite. And further, this was in the uncut state, just in the, you know, the object as it presented. And it gave actually some unreliable results, in that it was only looking at the taenite, at the high nickel part of this. The sample was then cut and etched and looked at in thick section, and that's when we discovered this thing just was hugely coarse grained. So, you know, to properly classify an iron, you make that thick section, you put it in the scanning electron microscope, you go in and look with a microprobe and look at small spots where, you know, that are on the order of a few microns apart across, and you figure out the elemental analysis spot by spot by spot, and you know that you're in the taenite grain or in the camosite grain or in some silicate or what have you inside the meteorite. So we don't really have any good techniques for classifying meteorites non-destructively. There's one slightly destructive technique called LIBS, L-I-B-S, laser-induced something spectroscopy, something that starts with B, and it actually burns little pits in the sample, and those, when they're excited with the laser and burned, they actually fluoresce in the visible light range. And that technique is really cool in that it doesn't require a vacuum, and it can be done on the outside of a rock. It is somewhat destructive in that it does make little pits. It's not super accurate, so you can't get down to the same spot size that you do with the electron microprobe. But turns out we've all seen this technique being used. The CAD on the rover is LIBS, L-I-B-S. So
laser-induced breakdown spectroscopy.
Thank you, Bruce.
I just looked.
Nice.
So that's an interesting technique that definitely has some possibility. Dr. Ralph Glasser brought up that technique on on some discussions that we've had on Facebook that have been very interesting. And that one, may have some possibility in the future as a significantly less destructive scheme. But so far, we don't have any good non-destructive schemes.
Yeah, the answer was no.
Yeah,
that's the short answer. Sort of led off with that. Thank you, Bruce.
Yeah. Thank you so much, Professor Pat. I really appreciate that. That brings us to the end of tonight's Knowledge Bolide Hangout. I do want to make an announcement that next week's topic, thanks to my beautiful wife, is going to be pretty Pallasites. And yes, I have to say that. Pretty Pallasites.
Thanks, Sue.
That's up to Sue. You got to blame her for that. Thanks, everyone. I appreciate it. Have a great week. Bye-bye.
Thanks all.
All right.
Bye.
Bye-bye.